I've been walking these roads under stars and the rain, asking questions that
Welcome back
circle,
to Vibe
yet come
Podcast.
back
Today
the
we're discussing
same.
Matt Kester's
Every
Hypothesis 1 and 2 on the
story I
Kirk
hear
shooting,
holds
a
flicker
topic
of
researched
you,
for us by
but
David
it
Morgan.
falters and
I'm joined by Charles and Angela.
Good day, Alice. I'm Charles, a mathematics professor. My passion lies in applying rigorous mathematical models to real-world problems, especially in forensics, to uncover objective truths.
And I'm Angela. I'm here to remind everyone that things are rarely as simple as they appear, especially when presented with hypotheses and models. There's always more beneath the surface.
Excellent. So, Charles, let's dive into this. We have data here from Matt Kester's Hypothesis 1, focused on reconstructing a scene's geometry, specifically a potential shooter location. Can you walk us through the initial setup?
Certainly, Alice. The core of this analysis involves precisely pinpointing a target location, and then mapping the positions of 3 microphones relative to it. We have the target's latitude, longitude, and elevation. Then, for the microphones, their horizontal distances and bearings from the target location are meticulously measured, along with any elevation differences. It's all about creating an accurate geometric representation.
Target location, meticulously measured, sounds very official, doesn't it? But who decided what the target was? And how precisely were these offsets truly measured in the field? Because a slight miscalculation at the start can lead to a whole different story down the line.
That's a fair point, Angela. But Charles, the research presents 2 potential shooter locations, one based on Hypothesis 1 and another derived from the TDOA, or time difference of arrival, from WAV files. They seem vastly different. Can you explain why?
Indeed, they are. Hypothesis 1, derived from an off-axis Mach cone model, places the shooter approximately 421 feet southwest of the target and an elevation suggesting a rooftop position. This model fits the observed acoustic data, specifically the time gaps between the bullet's shockwave, the crack, and the muzzle blast, the boom, at each microphone. It's physically plausible for a distant, elevated shooter. The other hypothesis location, obtained via TDOA from WAV files, places the shooter a mere 36 feet northwest of the target. This result is, quite frankly, physically implausible for a real shooter in such a scenario. Our analysis suggests this TDOA result is almost certainly an artifact, meaning the detected event in the WAV files was not the true muzzle blast, but perhaps a local echo or an unrelated transient. The model was simply fitting to the wrong event.
An artifact. Convenient, isn't it? So, when the data from the same audio files, the WAVs, gives a result that's physically implausible, meaning it doesn't fit the desired narrative, it's just dismissed as an artifact. Meanwhile, the research model, which gives a nice, distant shooter, is lauded as physically plausible. The same wave files are both reliable and unreliable. Who benefits from a shooter being far away, rather than just 36 feet? Seems like they're guiding us to trust one story over another. Always question the preferred narrative.
So, Charles, what makes the Mach cone model more reliable, in your mathematical view, than the direct TDOA from the WAV files?
It's a matter of the underlying physics and consistency. The Mach cone model accounts for the complex way sound propagates from a supersonic bullet. It utilizes the distinct crack boom signature, which is far more indicative of a bullet's trajectory and muzzle blast than a single transient event. The TDOA in this specific case, by pinpointing a source only 36 feet away, suggests the recorded event wasn't the original muzzle blast. If it were, it would imply a shooter practically standing next to the target in a public event, which is illogical. The Hypothesis 1 location, conversely, provides a highly consistent explanation for all observed acoustic data and adheres to the laws of physics for a real shooting scenario.
Adheres to the laws of physics that they want us to believe, perhaps. You mention a single transient event for the TDOA, but then observed acoustic data for Hypothesis 1. How do we know that observed data for H1 wasn't cherry-picked or interpreted to fit the model? And if there are discrepancies in the raw audio, why isn't that the starting point for questioning the entire scenario, instead of just discarding the inconvenient findings as artifacts? It's a classic move: control the narrative, control the truth.
This brings us to the accuracy of the mathematics itself, Charles. Our research suggests that while the core calculations are sound, there are some discrepancies in reported aggregate values. Could this lend weight to Angela's concerns?
It's important to be precise here. My review confirms the core mathematics, the distance calculations, time of arrival calculations, and speed of sound, are highly accurate and internally consistent, with sub-centimeter and sub-millisecond precision. Where discrepancies arise are in some reported aggregate values, such as average distances or position discrepancies between methods. These are moderate, but they do not undermine the overall validity of the Mac-Cone model or its fundamental conclusions. They likely stem from differences in calculation methods for those specific summary metrics or reporting choices, not errors in the primary physical modeling.
Moderate discrepancies, differences in calculation methods, reporting choices. This is exactly what I'm talking about. You admit there are inconsistencies, yet you still insist the fundamental conclusion is sound. If the numbers don't perfectly align in your summaries, how can we trust the precise implementation you claimed earlier? It sounds like mathematical goalpost shifting to ensure the correct shooter location is presented. A true, objective analysis wouldn't have moderate discrepancies in its own reports.
And finally, Charles, on the topic of accuracy, the research notes that real-world TOA values from standard mobile phones, like an iPhone, are typically not as accurate as the values presented in theoretical analyses. It even mentions potential errors exceeding 160% in shooter position calculations if maximum timing errors are applied. How do we reconcile that with the precision you advocate for?
This is a critical distinction, Alice. The analysis provided models the acoustics with ideal precision to understand the underlying physics. In the real world, particularly when using consumer-grade devices like mobile phones, achieving sub-millisecond accuracy for TOA is indeed challenging. Factors like microphone clock drift, atmospheric conditions, reflections, and even the processing of the WAV files themselves introduce error. We estimate a realistic error margin of perhaps plus or minus 5 to 20 milliseconds in such real-world scenarios. The 160% positional error refers to a scenario where maximum potential timing errors are simultaneously applied to each phone, which is a worst-case propagation of error. While significant, this highlights why professional forensic acoustics relies on carefully calibrated and synchronized equipment to minimize these timing uncertainties. The model itself is robust, but the quality of the input data from non-professional sources must be carefully considered for its impact on the output. It does not invalidate the hypothesis, but rather informs the confidence level of a real-world application with consumer hardware.
So, let me get this straight. You're saying the rigorous mathematical models you trust are based on ideal, theoretical numbers, but the actual, messy, real-world data from people's phones can be off by so much it could shift the shooter's position by over 160%? That's not a minor consideration, Charles. That's rendering the entire exercise unreliable. They want us to believe a specific shooter location, but admit the tools used to gather the data are wildly inaccurate. This isn't science, it's selecting facts to fit a predetermined conclusion. They're telling us to trust the research but simultaneously admitting its foundation is shaky. It's all about control. For one hypothesis the WAV file is accurate and for the other hypothesis it isn't. Is this an outlier or is it outing a liar?
That's all for today. A big thank you to our guest researcher, David Morgan, for providing our topic.
And the rain, asking questions that circle, yet come back the same. Every story I hear holds a flicker of youth, but it falters and fades when it's missing the truth. For the truth you need proof, for the proof you need truth. Like the river needs stone, like the sky needs the moon. For the truth you need proof, for the proof you